In this lesson, we will look at rational functions and their domains. Definition: a rational function is a function which is the ratio of polynomial functions. R is a rational function if it is of the form r of x equals p of x over q of x, where p and q are polynomial functions. F of x equals 2/3 is a rational function. It is the ratio of the polynomial 2 to the polynomial 3. G of x equals 2 over x plus 3 is also a rational function, as is h of x equals negative 3x squared plus 12x minus 11 over x squared minus 4x plus 4. Let's find the domain of some rational functions, starting with g of x equals x squared minus x minus 2 over x squared plus x minus 2. The domain of a rational function does not include values of x for which the denominator will be equal to 0. For g of x, this would happen when x squared plus x minus 2 equals 0. We'll factor x squared plus x minus 2 into x plus 2 times x minus 1. Set each factor equal to 0, and we see that when x equals negative 2 or when x equals 1, our denominator will be equal to 0, so our domain will exclude those values of x. Our domain will be negative infinity to negative 2, union negative 2 to 1, union 1 to infinity, and the graph of g of x will look like this. We'll have a vertical asymptote at x equals negative 2 and a vertical asymptote at x equals 1. In example 2, we'll find the domain of r of x equals 2x plus 2 over x squared plus 4x plus 3. We want to make sure that we do not include x values in our domain for which x squared plus 4x plus 3 is equal to 0. We'll factor x squared plus 4x plus 3 into x plus 3 times x plus 1. Set each factor equal to 0 to get x equals negative 3 and x equals negative 1 as the x values that need to be excluded from the domain. So the domain is negative infinity to negative 3, union negative 3 to negative 1, union negative 1 to infinity. And the graph of the function has a vertical asymptote at x equals negative 3 and a hole in the graph at x equals negative 1. In this next example, we'll find the domain of f of x equals 2 over x squared plus 1. We want to exclude values of x for which x squared plus 1 equals 0, which would be equivalent to x squared being equal to negative 1. There are no real values of x for which x squared equals negative 1. So in this case, our domain is all real numbers. And the graph of the function, as you can see, does not have any vertical asymptotes or holes. Try on your own. Find the domain of the rational function h of x equals negative 3x squared plus 12x minus 11 over x squared minus 4x plus 4.